Okay, so this video is a help video for the homework, and really it comes down to looking at frictional forces and how we can kind of solve for acceleration in that. Now the example that I'm using is going to be a box on an incline, and we really have kind of two different situations that we can look at. Our first situation is when we have no net force. Okay, and what does that mean to have no net force? Well, it means that either our box is going to be stationary, in other words, it's not moving, the box is at rest, or it means that our box is sliding with a constant velocity. Okay, so either we're at rest or we're constant velocity. Now, in all purposes, when we look at this, if I draw my free body diagram, okay, we're looking at an arrow that represents the weight of the box, and we're looking at an arrow that represents a force normal, and an arrow that represents our frictional force. Now, what we like to do with our situation whenever we have a box on an incline at some particular angle is we like to get everything in terms of components that are on the x-axis or on a y-axis. Now, when I look at anything on an incline, because I already have a frictional force acting parallel to my incline, and I already have a force normal that's acting perpendicular to my incline, I'm going to take my weight and I'm going to split it up into its components. Okay, and so I'm going to look at it in terms of a force that's acting perpendicular and a force that's acting parallel. Now, because there is no net force, our force of friction is equal to our force parallel. Okay? And that's because there's no net force. So those two forces have to be equal to each other. Now, to figure out a force of friction, you just have to know a coefficient of friction and our force normal. Now, the force normal in this particular situation is also going to be equal to our force perpendicular, because again, these two forces have to be in equilibrium when there's no net forces. So in other words, we can just substitute the force parallel, or perpendicular in for our force normal, and then we can figure out our frictional force. Okay, now that's kind of our situation given some coefficient of friction. Now remember, problems will give you two different coefficients of friction, one being a static, one being a kinetic. The static one is the one in which we're definitely sitting at rest, so that's usually our static sense. And remember that static friction is always going to be the greatest of all of our frictions. When we're at a constant velocity or we're sliding, this is when we're going to be our kinetic friction. Okay, so we have kind of our two situations when we look at this. So that's really what it boils down to when we're looking at a block at rest, okay, no net force, or a block sliding with constant velocity. Okay, now what we like to do is look at the other situation, and our other situation is the one in which the block now has a net force. So there is now net force, which means acceleration. So we now have acceleration. Okay? And when I draw my free body diagram again, my force of weight, my force of friction, my force normal. Okay, again, those are the same three forces. The difference here is that when I split up my components, so I get my force perpendicular and I get my force parallel, my force parallel is greater than my force of friction. Okay? Which means that I have a bigger force here than I do here, which causes me to have a net force. So my net force is going to be equal to my force parallel minus my frictional force. Okay? And so that's kind of the key thing whenever we have a block that's accelerating down the incline. Now, the same kind of cases still hold true as it did over here. The force perpendicular is going to be equivalent to my force normal. Okay? So I can actually look at it to figure out what my force of friction is. Again, I'm probably given an angle, and I'm given a coefficient of friction. Okay, so usually that is some number that's given to me in my problem. So that's going to be kind of how I look at these two situations. So again, my frictional force is going to be my coefficient of friction times my force normal, but my force normal is equivalent to my force perpendicular. Now, the harder of these type of problems is one in which they would like you to find the coefficient of friction, and we actually have the block and it's accelerating. Okay, and so I'm going to kind of walk through a problem that's going to be similar to question number 2 and 3 from the problem set. In question number 2, they give you a bunch of information for kinematics. So they give you like a velocity, distance, time, and what you can then find in number 2 is your acceleration. Okay, and that gives you the acceleration of the block going down the incline. So in other words, our block has acceleration, it's going down the incline. If we know that acceleration, and I'm just going to make up that maybe my acceleration was 1.5 meters per second squared. So maybe I have a 1.5 meters per second squared, and that's my answer from number 2. Okay, and I'm really working on number 3 here. So I know my acceleration based on my answer from number 2, and I know that my block has a mass of, I don't know, like, we'll just say 15 kilograms. Okay, so I have a mass of 15 kilograms, and it's going down the incline, and maybe my angle here is, again, something like 30 degrees. Okay, so I'm just working with some numbers that are going to be relatively easy to kind of see, and you'll be able to kind of see your numbers and how they work with that as well. If I draw my free body diagram, again, my situation here is that I actually have my weight, I have my normal, and I have my friction. Okay, and my component of the weight, or my force parallel, is actually greater than my force of friction. So in other words, my net force is equal to the force parallel minus my force of friction. Okay, well, I know my acceleration, I know my mass, so I know my net force. My force net is just the mass times an acceleration. So in other words, I have a mass of 15 kilograms, and I have an acceleration of 1.5 meters per second squared. So I know my force net. It's just my 15 times my 1.5. So in other words, I know how much force is acting down the incline. Now I can figure out my force parallel based on my triangle. And there's my triangle again. This is my 30-degree angle. And so in other words, the sine of 30 times the weight, which is 15 kilograms times 9.8, okay, that makes up F of G, okay, is going to be equal to my force parallel. So I'm going to take my 9.8 times my 15 times sine of 30, which tells me that my force parallel is 73.5. Let me just double check that. Okay, so that's how many newtons I have acting down. Now I need to come up with that frictional force. Okay, and so if I have 73.5 newtons of parallel minus the frictional force, I'm going to solve for my frictional force. Okay, so in other words, my frictional force is equal to the 73.5 newtons minus the 22.5 newtons. So 73.5 minus 22.5 tells me that I have 51 newtons of force that's actually being consumed by that friction. Okay, so in other words, that's my friction. So if I know now that my friction force, which is equal to a coefficient of friction times a force normal, okay, and my frictional force is 51 newtons, and my force normal is essentially the same as my force perpendicular. That's the 9.8 times 15, now cosine of 30. Okay, I can then solve for my coefficient of friction. So my 9.8 times 15 times 30 cosine comes out to be 127 mu 51. So divide by 127. Mu comes out to be 51 divided by 127. 0.402. Okay, and that's kind of how we go through and do those types of problems. So good luck on your homework, and again, remember, follow everything and use your class and your in-class time wisely, and we will see you on Wednesday.